Hey guys, this video is in two parts. The first section will cover making the non-printed components, including the parts for the headstock, the lead screws and the base. With that done, the rest of the video will be fairly unedited, with me assembling the rest of the mill and giving commentary. First, let's get the lead screws out of the way. These are not difficult to make per se, but I've had trouble finding a good way to illustrate the process. There are 3 screws for the 3 axes in this machine. X, Y and Z. The X and Z axis are both simple, and I'll explain them first. The Y axis is a little more finicky. I will use this jig here to show the X and the Z axis process, since it's easier to get on camera. Take a length of 3/16 threaded rod, 410mm for the X axis, and 160mm for the Z axis. I'm obviously using a small piece here to demonstrate, but the process is the same. Anyways, put the threaded rod through the assembly in question. Take a spacer nut and a hand wheel, and thread them on until they are tight around the part. The Z-axis retainer should be flush with the rod that it's on. The X-axis doesn't have any requirements like this. With the parts in place, glue the retainer piece with superglue. Drill through the guide hole with a 2mm bit. Use a M2 12mm bolt to retain the piece. Do the same thing with the hand wheel, except don't use glue. This is because one end needs to be able to come off for assembly. Hopefully that all makes sense. Now onto the Y-axis. The Y-axis process is similar, except the retaining nut is in a different location. The Y-axis retainer needs to fit flush into this recess in the headstock cap. To achieve this, thread the retaining piece on until you think it's in the right place. Put the cap piece on and see what adjustments need to be made. Repeat until the piece fits nicely in place. Glue with super glue and drill a 2mm hole. This piece needs to use a piece of 2mm rod or wire rather than a bolt, since there is no space for the head of the bolt in the headstock. Head cap? Yeah, that. Cut a 10mm length of 2mm rod or wire, insert it, and glue. Next, take the cap assembly off, add the hand knob, and drill another hole through its guide hole. This concludes the lead screw making. Next, we move on to the brass plates for the headstock. These are cut from this sheet of brass stock from K&S Brass. The stock is 30mm wide, and the plates required are 30mm by 50mm in dimensions, keeping cutting to a minimum. Cut 2 pieces of 1.7mm brass to those dimensions, and using this drilling guide, pilot hole all marks to 2mm. Enlarge these holes to 4mm, this one to 6, and this one to 10mm. Both pieces are identical. At this point, it's likely that this hole won't perfectly be 10mm. Mine came out ever so slightly under 10mm, which is actually perfect, since it allows for the bearings which are used to very tightly fit in the plates. Tap or press a 10mm outer diameter, 5mm inner diameter bearing into both of the 10mm holes. Finally, the spindle piece. This is a 50mm length of 5mm stainless steel rod, with a flat filed onto one end. Similarly to the lead screws, I put the dry pulley on and use the bolt hole as a guide to drill a 2mm hole through the spindle. With that done, so is the more difficult part of the build. Before we move on, here's a list of the lengths of 5 32nd rod that will be required for the rest of the build. Now, let's build the base. This is very much up to you, but I'll go over what I have and the requirements for any base that's made. I have 5 pieces of timber, made from 10mm ply and 42 by 30mm pipe. It's laid out in this fashion, pretty self-explanatory really. The 10mm ply is 40 by 25cm. The other timber is cut into one length 40cm long, and 4 lengths 20.8cm long. I've also made this set of pieces to make the front look a bit nicer, and to add some drawers to store tooling and the like. To use these drawers in your build, these support pieces need to be 10.5cm apart. The base has only 2 requirements: space for a 10mm nut underneath, and enough space to put the mill on the top. The location of all the mill parts are determined by the location of this 10mm hole. The centre of this hole needs to be at least 85mm from the back of the base, 160mm from the front, and 15.5cm from each side. If you want to use the lathe headstock attachment, you'll need to use an extra 6.5cm on one side. With all that out of the way, the rest of the video is me assembling the mill. It's pretty long, but it should give a pretty good idea of what's involved. Now over to improv me. Thank you for that, scripted me. This is over to improv me now. And I'm just going to build this entire thing bit by bit. You should have all of the non-printed parts explained to you. The rest of it is honestly pretty intuitive. There's not really many ways these parts could go. But I'm not really going to edit this too much. It'll probably be 15-20 minutes long. But if you're building this, I'm probably assuming that you would have the time to watch this while you're doing it. So, to begin with, you have the base. This hole, which is important, I've already been over that. Put that in. Probably put a bolt underneath it for the sake of making this video easy. I'm not going to do that right now because I don't need to. Take this. Ta-da! Put it over like that. Next, we're going to make this assembly here. I have it partly assembled because it's a pain in the ass. So these are 3/16 bolts. There's 2 of them on each side. This white piece is, you can flip it around, you need to print the same piece twice. These end pieces are different because of this hole placements. They're 2 separate support pieces. A previous version of the mill used some different support blocks. They are ambidextrous, I guess that works, so they can be the same either side. But anyways, so screw this in. This takes ages, that's why I've done most of them already. I'm sure you understand how to, you know, put a nut or a screw into a hole. It's not exactly a mentally stimulating task, but whatever, do that. Ta-da. You'll know when it's done. Anyways, so that's one side, and then do it again for the other side. Now this side you'll see is already bolted in, and we're going to do the same thing over here. So you should already have your brass inserts in there. Do a little number like that, and then take these ones. M3 bolts. There's a lot. Oh, is there one in there already? No? Okay. Get in there. M3 bolts. I think I'm using 15mm ones here. You could use probably up to about 30. The holes in there go quite far back. Because why not? Anyways, so just anyways, with this setup, you can kind of imagine where this goes. Now when it comes to aligning all this, it's just kind of up to you to make it straight with your thing. I've already done all the pilot holes. That's another thing that I'm sure I don't need to explain. But actually, before we screw that down, let's go. So see pilot holes there and there. This piece here is to stop. You probably no way you can see it, but if you screw directly into here, you can kind of see it at the back there. You are going to destroy the print, because prints don't take, and they're not that fond of having a large amount of compression in a narrow area put onto them, so the print will split apart. So this white piece here is just to spread the weight more evenly on a piece that's slightly more disposable, while still adequately camping everything down. Okay, next up, there's a similar setup for the back. Now this is a relic. Originally I planned, in the style of watchmaking drill presses, to have the belt go from a motor here up and over. That probably could work with slightly nicer hardware, but I found it impractical and unnecessary. So, that back piece is outdated. Use essentially this version but for the back. But in the spirit of not printing more than I need to, this back piece is what I'm using. It does serve the same purpose as this, isn't that I'm saying? Cool. So that's down. And now this just lines up. So, to reiterate, get this, it's easy to get this nice and straight, and then this will, in turn, be straight with it. So, with that done, we're now going to do all these screws. Enough. Next, this piece here, this supports the front of the cross slide quite a bit. That will slide in very neatly there, just like that. And then a similar process. I'm using these very small wood screws because this is 10mm plywood. If I used larger ones, that it would go through into the drawer. That's why I'm using such small ones. So again, pre-pilot hold. With that done, we're then going to move on to the first slide, I believe. So, before we put it on, this setup here, you can see, again, already partly screwed together, because who the hell wants to watch me bolt screw, I need to get my terminology right, bolt screw whatever, twist things for extended periods of time. So, in here, this doesn't have brass inserts, as you can see. This is just 3mm bolts through here, and then the 3mm bolts all through here. The front of this does have a space for nuts, the other end doesn't. That was for a reason, I can't remember what it is. And I'll also touch on how the captive nut is held in place for the lead screws at this point. This looks janky, it's because it is, but hey, it works. So pretty much right in the middle here is a nut. And the way that I've been holding this in is just hot glue. The process for that is put your rod and thread it through the nut so that it's aligned and centered nice, and then just put the hot glue in, and then unscrew the rod. And that is all there is to it. It's pretty simple, and I've used it on the lathe and the mill, and it's held up just fine. I haven't had a problem with it. So, next up we're going to have to go undo all of our hard work. And by all of our hard work, I mean one side of it. Okay, so once we've taken that off again, we're then going to take these rods and insert them. You can have up to, what's that? 5. 5 rods is the maximum you can have. I would recommend using this front one. That one's quite useful, like a back one. I do have a bunch more of these, and I can't for the life of me find where they are, but you get the process, I'm sure. Okay, next up, before we put this on here, we're going to assemble the next part of the cross slide. So we're going to take the 85mm lengths, not the 90mm lengths. I just had to reshoot this because of that. Chuck them in here, like so. Next up, I'm going to take this slide, chuck that in like so. Then we're going to take this piece, that slots on the other side, just like that. Very neat, very cool, very good. Next you're going to realise you've put all your M3 bolts somewhere. So you're going to take other M3 bolts. Oh, I know, there's 2 in there. Huh, who would have thought? Not me, apparently. And then you're going to find what's definitely not the right Allen key. Heck. Okay, I'll be back. Okay, next up, after searching through your Allen key collection and finding the correct Allen key, these 4 corners also going. Okay, at this point you have something like this. There's a captive nut in there, and then on the back side, so the side that has this little ledge, I'm going to insert this and then just twist it through. Next, take one of these. I should have gone over these lead screws already, so this should all make sense. do one of those, get it nice and tight. Then we're going to take our first hand wheel, put it on like so you can see through the hole. I'm going to take an M2 bolt. Once you have the appropriate Allen key. Now there's a bit of a space here, you know, so that's good to know. You're probably, with the method that I made this, it's very imprecise. So you're probably going to need washers of some type. Or else there will be slop, and that will be annoying. So washers are another thing that you can use to fix that issue when and if it arises. So that went through real easily. And we now have our first slide, if we turn it the right way. Anyways, with that done, we can now go and thread that onto these rods, like so. Ow! Careful not to shred your fingers on sharp edges. Wow, isn't that nice? Next up, we can go assemble this back again. Cool. Okay, so next up, we're going to take this one and take the fun process of threading this all the way through. If you want to be quick with this, you can use a drill. You're just threading it through the captive nut all the way through. Cool. With that complete, support piece that just screws onto the side like this. This was a rough up of a measurement system that isn't completely done, so just ignore that. If you've made your base more narrow than mine, you won't have to borrow with this. Borrow? Bother. Oh bother. Anyways, check that that's as tight as it can be, and to bolt down through here. Anyways, with that in, we now have slides. How fun! Okay, there's not much more to do. How exciting! So next up, we're going to take the 90mm brass rods, and they're going to go in here. I mentioned it before, but in the top here there are 3 more brass inserts. Next, I'm going to take this one. This one is going to thread through here like this. Oh, also exciting. You put your collet chuck on there as well, that kind of just goes without saying. Mine is currently on the lathe. There we go. chuck that there. Take your cap piece, line that all up. Ta-da! Now, obviously, if you've bolted at the bottom, which you should have like me, this is quite an important step. So, this setup here would obviously clamp this whole thing down through the board, and it kind of compresses all the layers and keeps it very rigid. So that is an important step to do. Next up, so do that. Also put 1, 2, 3 and 3 bolts in there. To finish, I'm just going to take this hand wheel, and if this will let me, do it on, bolt it in, and there you have it. The basic mill. Ho-ho! Thought you were done. Or I thought I was done. I actually just went and did the intro, or the outro and everything. I forgot a step though. It's quite an important one. It's the arms. So, to make the arms, I'm going to take 4 of these bolts and bolt them through these little pieces here. Like so. Four of these little bits. 2 bits. 4 bolts, 2 bits. And we're just going to do this. There's one done. Same thing with this one. These are the support arms for the headstock, and they actually provide quite a bit of rigidity. They're technically not essential, but they made it work much better, I found. They're actually quite important. And they're pretty simple to make. Also, they make it look much cooler, honestly, most importantly. I'm doing this, also touch on the motor. So obviously it's belt driven. What I used to do was just bolt a sewing machine motor to the wall over there. Again, with the whole preoccupied with the lathe thing at the moment, so not going to be doing that, but that's all the advice I can give really. I'm not really good with the whole electronics thing. I'm sure there's many motors on eBay that you could use to hook up to this thing. Anyways, make that nice and tight but not too tight. I'm going to do the similar thing with this. There we go. 2 of those. Push that out. This is the annoying bit, is getting this one in. There we are. And then put another nut. This one. There you have it. Now, it's properly actually done with the arms that I didn't film in the last intro. So, same intro as last time. Hopefully this helped. I think this should cover pretty much everything. Sorry for the longer video, but, oh well, that's how it is. Thanks so much for watching. I've got some more cool projects coming up, so if you haven't subscribed already, maybe consider doing that. Although I figure if you just watched a half-an-hour video, you're probably already subscribed, I would guess. I don't know. Yeah. Thanks as always, blah 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 blah, and see you next time.